The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, or even good morning, depending where you are in the world. Thanks to all of you for joining us today on our discussion on alarm or minimizing alarm proliferation. Firstly, we'll just do a quick introduction. So, for those of you who may not know who we are, who Mac Solutions are. We are the creators of the ProcessVue alarm management suite of software, which, according to a recent ARC study, is the most popular independent alarm management software as used in the European power generation markets. We offer alarm management software, services and training, and we are based here in the UK with a few offices dotted around as well, one in Paris and a reseller network across the globe. So joining me on this webinar is Mr. Ian Brown, who's our alarm rationalization services manager. Ian has many years experience in the process industries in roles ranging from maintenance management, control system management and consultancy. His expertise covers the alarm management standards and guidelines and is also a TUV certified engineer. And then there's myself, Jason Cook, having worked for iMac back in the day and Matricon and Honeywell in the alarm management arena. Over the last 13 years or so, I've held roles in technical support, site engineering, sales, marketing, and I'm now the ProcessVue product manager. So with the introductions over and done with, I will hand you over to Ian, who will guide us through the main body of this presentation. If you have any questions during the presentation, you should be able to key them in to the interface that's on your screen. We definitely would like to hear from you if you do have any questions, so don't be shy. And at the end, we will answer those questions for you. We'll have some question and answers time at the end. So that's all from me. I'll come back at the end of the presentation. So I'll now hand you over to Ian.
Thank you, Jason. Excuse me. And welcome to everyone who's tuned in for this webinar. This is a small webinar about how to minimize alarm proliferation when you replace your system with a new system, you upgrade your system to the latest, greatest system with the same vendor, and it's also applicable to projects, new projects. So how do you make sure you don't end up with more alarms than you wanted when you change your system? So that's what this webinar is all about. Okay, so your slow, obsolete system that you can't get spares for, your vendor won't support, you're going to replace it. And you're either going to upgrade to the latest, greatest system that they offer, or maybe you'll replace the system with a brand new system from a different vendor. And that's a good thing, isn't it? Because your system's not working very well, perhaps it doesn't have all the features and functionalities that you wanted. Now your new system will replace it, so that's much better for your operation, for your operators, for your plant, your facility. It's a good thing, isn't it? Okay, so if it's a good thing, is there anything you need to think about to make sure that everything goes smoothly and from a system that runs fairly reasonably well, it's obsolete, but it runs okay, and the operators aren't too bothered with too many alarms, you've got a fairly stable system. How do you make sure anything you need to think of to make sure you don't end up with tens, hundreds, thousands more alarms than you have now? So we're going to go through some of the things of why things go wrong, what you need to think about. So why do problems occur? You have a system that's working, you're going to upgrade with the same vendor, or you've got a system that's working and you're going to change vendor. Why would problems occur? Fundamentally, management of change. Everything is down to management of change. You are changing, upgrading or replacing, and you need to manage that change. So management of change is basically the root of all evil. So with your management of change, what about inadequate documentation? You should have an alarm philosophy. You should also have an alarm system requirements specification, an ASRS. Those documents define how you are going to manage alarms at your facility, within your business, what you expect your system to do, and how you expect it to behave. So you need to have good documentation when you manage change. What would I like my system to do? How would I like it to be? Included, once you've got your basic documentation in place, other things that could go wrong. Poor project management. You may have an internal project department with project managers who run all sorts of projects, from upgrading an alarm system to building a new plant. They're well versed in project management. You may believe that your vendor or your third-party integrator will give you the system you want. You tell them, this is what I expect, and they'll give you exactly what you want. Maybe. They may not know or understand the new system very well. You may not know or understand the new system, whether it be a completely new system or an upgrade. You and your vendor, your integrator, may not understand all the functionalities. When any work is done to upgrade during the upgrade process or migration, if engineers aren't properly trained, they may not configure the systems correctly. They may use lots of defaults instead of using what you really need. And time and cost come into this as well. Problems occur because people have to squeeze things in quickly. They miss out bits and pieces of work that they should have done because they haven't got enough time to do everything. Or they simply won't do all the things you think they should do because you've only paid a small amount of money. You haven't paid for all the extras, all the good things that we could do. You wouldn't pay for that, so we're not going to do them. So basically, management of change is at the root of why things go wrong when you're upgrading or replacing your system. So when you upgrade or replace your system, what exactly do you want? You want a usable system that is no worse than the system you currently have. It's no point in taking a working system and putting in something that doesn't work as well. You don't want a degraded system. You want something that's much better. That's what you're looking for. And if we think about the EMEA guidelines, the EMEA guidelines are based around 4 core principles: usability, safety, performance monitoring, and investment in engineering. Okay, when you're upgrading or replacing your system, think about usability. Alarm systems should be designed to meet the user's needs. Okay, so what does the operator want? What does the operator need? And operate within the user's capabilities. It's no good putting in a system that all of a sudden has 500 alarms per 10 minutes. The operator will simply not be able to manage those alarms, and so it's not going to operate within his capabilities. So usability, that's fundamental to any change, making sure the system is usable. What about investment in engineering? You're going to replace your system, for example. You're going to pay quite a bit of money to do so. In here, I've underlined in one of the core principles from the EMEA guidelines, the wording: initial investment in design should be sufficient to avoid the operational problems and the safety, environmental and financial risks that often arise, which result in overall higher lifetime costs. So if you don't manage your upgrade properly, the project gets closed out, end of story, but you still have problems that you have to resolve if you don't manage your change correctly. So it's worth paying and spending the money to get the system that works and gives you what you need, rather than delivering a system which only does some of the things you want and the rest of the cost falls on operations. Are they going to have all the trouble, the hassle of dealing with those problems, paying for those problems? That's what builds up over time, over the lifetime of your system. So if you do the system properly during your change, your upgrade, and spend the appropriate money on the things you need to have done, then you should have fewer problems. Okay, let's consider how you're going to manage change. Hopefully, most people do, you will have a management of change process. And it could be great. It's a multifaceted thing. You have lots of stage gates, you have risk assessments. When you come to build a new plant or move a vessel, you will know if you need a lift plan for a crane. All of those things, all those big things, generally are covered very well in management of change. But what about alarms and alarm systems? Alarms, if I want to change a set point on alarm, how do I go about doing that? Is my management of change appropriate for managing alarms and alarm systems? Quite often, the answer to that is no. When I do benchmark assessments on alarm systems, regularly, operators and maintenance staff, supervisors in control rooms, tell me that they don't use the management of change system because it's too onerous, it takes too long, there are too many steps to take. I want to change a set point from 37% to 54%. I have to fill in a form, give it to my supervisor, who signs it, gives it to the plant manager, who signs it and approves it, sends it to head office, who then take their time to look at it, sign it, approve it, send it back, etc., etc. It may take 3, 4, 5 months to get one simple change made. We don't use it. Nothing would ever get done if we used our management of change system. It's just not useful for alarms. So if you don't have a system that is useful for managing alarms, you're going to have problems. And you'll have problems as you upgrade, as you replace. So make sure that your system, your management of change process is appropriate for alarms. For example, does it include software acceptance testing? What about a factory acceptance test for software? What about, for major changes, a site acceptance test? Does your management of change process include for that? Quite often the answer to that is no. I can buy a crane and operate a crane, but I can't test my software. It's not in my management of change procedure. So make sure your procedure, your process, management of change works and is appropriate for alarms. If it isn't, you're going to have problems, because things will get missed, things won't get done, and that's why you'll end up with more alarms than you wanted. What about documentation? How good is the documentation that you actually have? I mentioned earlier an alarm philosophy, which most people know about. We have an alarm philosophy? Yes, we do. But what about an alarm system requirements specification? I mentioned this document on an earlier slide. Quite a number of people will probably think, what is an alarm system requirements specification? Okay, and an ASRS documents the alarm functionality expected of the control system. What is it you want your control system to do, your alarm system to do? What is it you expect it to do? These are the features and functionalities that I require. That's what your ASRS documents. If you don't have that and give it to your vendor, to your third-party integrator, then they will give you the system they think is okay, but not necessarily the system that you want or expect. These 4 points here, bullet points, are taken from the standards. They are little clauses taken out of the standards. So an ASRS is used to help evaluate systems. If you're putting in a new system, does it have the features and functionalities that you require, that you want? It serves as the basis for alarm system function testing during implementation. Remember, we talked about our management of process, management of change process, and software acceptance testing. Okay, it's typically generated early in the planning for a new control system. So before you buy a new control system, you should have an ASRS, which determines what you require from your new system. And again, planning for new control systems and major revisions to alarm functionality should include an ASRS. So if you're upgrading your current alarm system to the latest version, which has new functionalities and features, are they the features and functionalities that you want, or do they not include those? So an ASRS is a really important document when you're managing change. Don't leave it to chance. Make sure you have a philosophy and an ASRS, and make sure that your vendor, your third-party integrator, your project manager, anyone involved in that change, make sure they have those documents and work towards them. Okay, I've just mentioned a project manager. Does your project manager really understand what you want from your system, what you require from your system? Well, of course they do, because they're going to manage the project for me. Is that really the case? Is your project manager committed to delivering the system you want and need to operate the plant, or delivering a project on time and preferably under budget? Once the project's closed, the project manager moves on to a new project. Was that a success? Yes, delivered on time, on budget. Oh, well done, project manager. Does it actually deliver what you need and want? That's debatable. So will your project manager cut corners to complete? One of the core principles of EMUA, engineering investment, it states contract strategies should be chosen to ensure alarm systems are engineered to good standards. Will you get an alarm system engineered to good standards if your project manager isn't committed to delivering exactly what you need? I worked with a major company fairly recently. They had a project manager managing the project where they replaced an older control system with a new control system from a different vendor. The system delivered. I did a benchmark assessment on the system and determined it wasn't fit for purpose. The system crashed almost every day, sometimes twice a day. It generated thousands and thousands of alarms that had already been generated and weren't repeating. It didn't present alarm information to the operators. So on the screen, an operator could not see an alarm set point or an alarm limit. All they could see was a number which converted, a conversion factor from the 4 to 20 milliamp to the screen. There was a conversion factor available to the operator, but is it a 57% alarm? I don't know. I can't see it. The operators had to contact the configuration team and ask them, what's the alarm set at, please? Which is great between 9 and 5, but between 5 o'clock in the evening and 9 o'clock the following morning, the operators were operating blind. They didn't know what alarm limits were. That's fairly fundamental to operating an alarm system. It wasn't delivered. The project manager didn't deliver it. The vendor didn't deliver it. So the system was pretty useless. And the reason these things were missing and weren't picked up before it was installed, there was no system test or acceptance carried out due to time pressures from senior management. We've got to get this project done. We've got to get it completed. So the project manager completed the project, missed out on software testing, missed out on other things, and therefore the system delivered. Once it was installed and handed over, the project's closed, on time, in budget, but there were loads of problems for the operations people to have to deal with, loads of issues they needed to get resolved, all of which came at an extra cost because the vendor had closed the project. The project's been delivered, signed off, you've paid for it. If you want anything else, you'll have to pay us to make changes. To be fair, the vendor did work hard to resolve the issues that came with the system, but they should never have been there in the first place. The system should never have been installed and handed over until everything was done properly. So yes, the project manager was responsible for the project, but didn't deliver what was needed and required. So keep an eye on your project managers. You don't have to micromanage the project. That's what your project manager is there. But make sure they're going to deliver exactly what you want. So if you don't project manage your project manager, you may end up with problems. Will you get the system that you really want? That's a question you need to ask. Well, of course, your vendor knows the system best. Your system integrator knows the system very well. So they will give you what you're asking for. But do they know the system very well? That's a good question. You've given them your philosophy, your documentation, your ASRS, so everything's great. What could go wrong? They know the system, you tell them what you want, no problem. We should end up with a brilliant system. However, not everyone at the vendors, engineers, not all of the vendors' engineers or third-party integrators actually know what the whole system does. What are these new functionalities? We've got a new version to roll out. I've never used it before. I don't know what the parameters are for. They don't know how the new functionalities may impact your system. It happens. It has happened regularly, plenty times. Have you been told how new functionalities will affect your system? What differences it will make? Do you know about that? Has that been made clear to you? Maybe the upgrade is being carried out during a service visit. So the engineer arrives with a CD, does his service, pops the CD in, upgrades the software, and that's where the problems start. Because the engineer doesn't understand about the upgrade, he doesn't know what the parameters are, what the functionality is. I worked with, again, a customer fairly recently, and during an upgrade, there were differences noted between the original system and the upgraded system. The client quite reasonably asked, what's this parameter? What does it do? The engineer didn't know. What's the difference between the old value of 2 and the new value of 1? Is it critical to operation of my plant? Will my plant run if we upgrade that system and use that value? The engineer didn't know. He actually shared configuration screens by WhatsApp video with a colleague in a different country to ask him the questions. The engineer didn't know what the new parameters and functionalities were, or what they did, or how critical they were to the plant. So although he was installing the upgrade, not quite sure how it works. So these things do happen. So has your engineer, has he been properly trained? Does he fundamentally understand things? What happens when things go wrong? As I said, the engineer here, he spoke to someone else in a different country via mobile phone using a WhatsApp video. Not great. The engineer didn't understand. So you may not get what you expect simply because you believe the vendor and third-party contract, they're going to do everything properly. They may not. Time and cost, I mentioned earlier. When you replace or upgrade a system, someone has to make a decision about spending the money. Are you going to upgrade with the same vendor to the latest system, or are you going to put a new system in? Quite often, another vendor will come in and offer to replace your system completely with a complete everything brand new for less than the cost of upgrading your old system, which still retains some old components. Upgrade, you've still got old components. Put our system in for less money and everything's brand new. So, that sounds great, but sometimes your purchasing department will make that decision for you, and they'll negotiate hard. They'll make sure they get the minimum price for the upgrade, for the replacement, and they may impose timescale constraints. You may have timescale constraints. For example, we have a shutdown in 3 months' time, and the next planned shutdown is in 3 years. So this must be done in 3 months. We've got to get that in. We've now got the purchase order. We've got our budget through. We have 3 months. So that puts pressure on the vendors, the third-party integrators, to do only the things that they need to do, only the things you've asked, no extra checks, nothing exciting, and to meet your schedule and remain budget, that's what they're going to do. Only what you've asked. Is that what you need? Potentially not. Sometimes you need a little bit more than what you've really just asked for. I'm going to talk about configuration issues. You only get what you pay for. Okay. System upgrades. We talked about an engineer coming to site and putting a CD in as part of a maintenance visit. The upgrade contains new features and functionalities. Basically, I'm here for a maintenance visit for a day. We'll upgrade your system. It will only take half an hour. In that half hour, all of a sudden you have new features, new functionalities. Is the engineer going to go through 5, 10, 20,000 alarms and set all the parameters appropriately for each alarm? Not in half an hour. You haven't paid for that kind of checking. All you've paid for is someone to put a CD in and upgrade your system. So you're going to potentially get a whole load of default values. Potentially there are going to be tens, hundreds, or maybe thousands of new alarms that the operator didn't know about, you don't know about. All of a sudden things happen. Where did that come from? How did that happen? What does that mean? And nobody knows. You've upgraded. It was a simple upgrade. It's causing you problems. For new systems, the number one offender, as with system upgrades, default values. Where they had no time to do the check in the half-hour upgrade to put correct parameters in, they put defaults in. With new systems, because we're doing this at a very reasonable price, we can't afford to look at every one of your alarms and make sure they're all correct. And we have other functionalities that your old system didn't have, that you couldn't even dream of. We've got all these things. We'll set them by default because we can't go through 30,000 alarms and change all these parameters individually. So I've seen systems where a new system was installed and all priorities were set to high priority for every alarm by default. Instead of doing individual alarm priorities dependent on the consequence and time to respond, they simply set them all to high because it was quick, easy to do, and therefore achievable within budget. A major global vendor set the return to normal condition of an alarm to an alarm condition. So if you had a priority 1 alarm for a level, you had a priority 1 alarm. When the alarm cleared, you had another priority 1 alarm. I did a benchmark assessment on a particular system from this global vendor, and I was a hero because I cut their alarm rate by 50% not long after I arrived on site, simply by saying, why is the return to normal condition set as an alarm? We took that away. It had been set by default during a system replacement. So easy to do, less easy to sort out. So you only get what you paid for. System replacements. Just mentioned about the return to normal condition. This was from a system, same vendor, unfamiliarity with a different system. They were replacing a system, different country, different engineers, same global vendor. They migrated from an old system to their system, different system. They weren't familiar with the old system. They probably used a migration utility, which generally doesn't take 100% of your configuration, or if it does, it may not do it fully correctly. There will be new parameters in the new system, which migration may just set to default. We can do this in a day. Everything gets set to default if it's never been used before. So you may have new alarm parameters, alarms that all of a sudden happen that you never had before. Also, you'll have parameters which currently exist. You have, for example, and this happened on a system I assessed, deadband. You had deadband on the old system, deadband on the new vendor system. This global recognized vendor, they migrated a deadband from one system where the values were set, for example, to 2, to their system, which had deadband. So they set 2 to 2. Fantastic. The problem was deadband can be expressed as engineering units or percent. The original system used 2%. The new system installed by the vendor used engineering units. So on the old system, 2 on a range of 0 to 5 bar, as shown at the bottom of the slide, meant a 0.1 bar deadband. So at 3.6 bar, an alarm point, you had to drop below 3.5, the alarm cleared. When they transferred to their system, they transferred the 2, simply put 2 in everything. That meant 2 bar deadband, not 0.1 bar deadband. The system was cluttered up with standing alarms. The alarms never cleared, went into condition, and this was done by a migration utility, by people who didn't understand what the old system did. Therefore, they just blindly copied values, and that caused all sorts of alarm problems. All the things that were set by default, hundreds of new alarms that they didn't want, including the return to normal alarm. So think about what you're getting. Talking about parameters and unfamiliarity with the previous system, although not exactly an alarm issue, what about loop tuning parameters? Something you might need to think about. Poorly tuned loops are a cause of nuisance alarms. They can be a real significant contributor. If you're moving from an old control system to a different control system, make sure your migration people, whoever they be, understand what the old system was set up as, what the new system was set up as. Gain and proportional band in controllers are not the same. This vendor who did the return to normal, who set the dead bands in correctly on a different job, different plant, different country, different engineers, same issue, problems. They copied the gain, reset, and rate values to proportional, integral, and derivative values. They took PI controllers and set them into their default PID controllers and set the rate action, the derivative, to 0, which stopped the controller from working instead of using a PI controller. So when you're migrating, you need to understand what were the previous values. Are they the same as our new values? The engineer in that case didn't understand that there was a difference between one type of 3-term controller and another type of 3-term controller. So they didn't understand, they weren't familiar, so they simply transferred values. So that caused problems. So you need to make sure that people understand the system you're coming from and going to. What about embedded code behind graphics? Sometimes people write little bits of Visual Basic behind graphics to do particular things. Does that get transferred in migration utilities? Quite often not. I worked on a batch plant for 10 years, and I was responsible for the control system. In the control system, there were valve controllers, and as part of them, they had logic steps. On the reactors that I worked on, small batch reactors, I had put an interlock on a nitrogen valve to stop the nitrogen from overpressurizing the reactor and rupturing a bursting disk. After I left, about 18 months later, the research chemist rang me, good friend, and said, "Why are our bursting disks all rupturing? They never happened when you were here." And I asked him to go. I said, "Okay, well, did they do this? Did they do that?" When the system was replaced by a new control system from a different vendor, did they transfer all these things? The research chemist went into a meeting and said, "Have you checked these things?" The vendor went away. No, they hadn't. So they had no interlocks to prevent the nitrogen valve from purging the reactor, and so it just kept pressurizing and pressurizing until the bursting disk ruptured. That wasn't taken as part of the migration. They didn't understand the old system, so they just did what they knew, and that caused problems. So, understanding what you're doing and making sure you document everything and you keep an eye on people. Why do alarms proliferate? Poor management of change, not controlling your change properly, poor documentation, all the things I mentioned on the early slide, not understanding the newer upgraded alarm facilities, inexperienced engineers, poor configuration, use of defaults, inadequate understanding of the differences between two systems if you're replacing a system. These are the kind of things that if you don't keep an eye on them, and don't forget the project manager who didn't do software testing that I mentioned earlier. So you need to keep an eye. It's your system, your responsibility. So you need to make sure these things are going to be done properly. Okay, so how can I prevent proliferation? How can I prevent things from getting worse during change? Make sure you have your alarm philosophy and your alarm system requirements specification. Make sure they're current and they give you what you want. This defines what you want. Make sure your project manager, your vendor, your third-party integrator, they have copies of them. They understand they must work to these documents. This is what I want delivered from my system. Make sure they understand your requirements and make sure you double check that. Make sure that if you're changing system, even upgrading, that your configurer, your vendor, your third-party integrator, whoever's making the change, make sure they fully understand if they're different system, what the differences are and how they're going to mitigate those differences. That says too, it's easy to copy a 2 from there to a 2 there. On my system, I'm going to have to do calculations for every single tag. Oh, I've now got 10,000 calculations to do instead of just a simple copy and paste. That will take a bit longer, but you need to do it. So make sure your people understand the differences. Understand you need to think about how the migration is going to be achieved. Will it simply be a little bit of software that goes, put 2 into 2, it's the same parameter? How's it going to be done? How's it going to be achieved? Migration tools can be brilliant, but not 100% brilliant. And they can't replace knowledge and understanding. Do you know what the old system was? Does your migration tool really understand it? Has it been really configured? You can't beat understanding and knowledge. And ultimately, the change that's happening, whether it be an upgrade, a new project, a new control system, is your responsibility. You are the one that's going to have to live with this system once the project is closed. You need to make sure that everything's been done correctly. You may not need to micromanage the project, but you need to make sure your project manager is doing all the things your project manager should do, such as not simply closing the project and installing without software acceptance test, like we had earlier, I mentioned earlier. Make sure they're going to do everything. You don't have to do this every minute of every day, but keep checking. Keep making sure your vendor is doing the right thing. It's your system, your responsibility. It's up to you to make sure these things are done correctly. So there's no easy way to prevent proliferation. You have to work at it, and you have to check, and check again. Okay, hopefully some of those things probably you recognized, maybe 1 or 2 things you didn't recognize. So just think about things as you manage change. Managing change is down to change of management. When that works correctly and everyone follows it, you have no problems. If you don't make sure your management of change is managed correctly, you're likely to have problems. So I don't really have anything else to say. So at this point, I'm going to close the webinar and hand back to Jason to see if anyone has got any questions on anything I've said or would like to ask anything. Jason, over to you.
Okay, thanks, Ian. Some useful information there. Thank you very much. If you do have any questions, guys, as I said, you can key them into the interface that's available to you on the screen. We don't have any at the moment, so I'll give you a few minutes just to think about that and key them in. There is a handout available on this presentation. Again, you should see that on your screen there. There's a white paper on this subject which you can click and download. The webinar will also be uploaded to our YouTube channel within the next couple of days or so. So if you go onto YouTube and search for ProcessVue, you'll find our channel there and all the past webinars that we've recorded and uploaded. Equally, if you go to our ProcessVue.com website, which is on the screen there, you can view the webinars there. You can see product videos, and there's a whole host of other white papers available for download as well, free of charge. So we do not have any questions. So I guess we'll close the presentation. Thank you all for attending. We will be in touch via email when this has been uploaded to YouTube, and we'll also be in touch when the next webinar is scheduled, and we hope to see you all there. So thank you very much, and have a good evening. Goodbye.
Thank you and goodbye.